Investigation of Curves, Section 4, Envelopes and Arc Lengths. Video 3, Arc Lengths, Polar Curves. In the previous two videos, we've seen how to find arc lengths in parametric and Cartesian equations. Let's see how to do it with polars. Well, we can go back to the expression for parametric equations, so S equals dx by dt all squared plus dy by dt all squared, all square rooted, and then integrating that dt. And we can use x is r cos theta and y equals r sin theta. So dx by d theta is minus r sin theta plus dr by d theta cos theta, and dy by d theta is r cos theta plus dr by d theta sin theta. Now, when I square and add these, I'll get an r squared sin squared theta from here and an r squared cos squared theta from here. So when I add those together, I just get r squared. I'll get a dr by d theta squared cos squared theta here and a dr by d theta squared sin squared theta here. So when I add those, I just get dr by d theta all squared. And then I'll get some cross terms. So I'll get an r sin theta cos theta times 2 with a minus sign in front of it from here, and a 2r cos theta sin theta with a plus sign in front of it here. So when I add those together, they cancel out. So I'm just left with S equals the integral of the square root of r squared plus dr by d theta all squared d theta. So there's that written out neatly for you. So let's have a look at how to use this in an example. Find the full length of the curve with polar equation r equals sine 2 theta plus 1. So we looked at this curve in a previous video. Well, firstly, I want to work out dr by d theta. So dr by d theta equals 2 cos 2 theta. And then using my formula, I've got that S equals the integral from 0 to 2 pi of r squared, so that's sine 2 theta plus 1 all squared, plus dr by d theta all squared, so that's 2 cos 2 theta all squared. That's all inside my square root, and then I'm finding the integral d theta of that. Let's do this using the computer algebra. So I'll start with my expression for r. So r is sine of 2 times theta. I can use alt and t to get theta, and then plus 1. And then I want the derivative of that, so the derivative of expression 1 with respect to theta, and that gives me 2 cos 2 theta. And now I want the square root of expression 1 squared, that's r squared, plus expression 2 squared, that's my dr by d theta all squared, and that gives me 2 cos 2 theta all squared plus sine 2 theta plus 1 all squared, all square rooted. Now, I need to find the integral of this, so I do the integral of expression 3 from 0 to 2 pi, and I get a question mark. My computer algebra system cannot evaluate this integral. But not to worry, we can use a numerical approximation to the integral instead. So instead of using the integral function, there is a function that I can use called n integral. So I type n integral. This gives me a numerical approximation to the integral for anything it can't work out analytically. So we've got the n integral of expression 3, and I want to go from 0 to 2 pi, and it numerically approximates it to 11.04. Now I might want some extra decimal places for that, so let's say round it to 5 decimal places instead, so 11.04138 there. So I can write this down I can say that I evaluated the numerical integral, evaluating the integral numerically gives s equals 11.04 to 2 decimal. In this video, you've learned how to find the arc length of a curve defined by a polar equation.